Okay, hello everyone. So we're going to go over our module 6 where we will be talking about all different kinds of organic molecules. So in module 5 we talked about the hydrocarbons, alkanes, alkenes, alkynes, and arenes, and today we are going to cover alcohols, aldehyde, ketones, ethers, carboxylic acid, and esters. So I know it's a lot to squeeze in one module, one lecture, but we are going to just touch briefly in all of them. Okay, so when we are going over all those, we are going to talk about in terms of functional groups. So in each of them, we are going to have a group that's called alkyl group, which is like our substituents that we've been talking about in module 5. So R is anything with carbon and hydrogen. So it could be CH3, it could be CH3, CH2, and it can, go on. So the minimum, it would have CH3. So if you have a R group attached to O and H, so directly to our group, there is O and H that we will call it alcohol. And we will go into each one of those. Then we will have an ether. Instead of H now, you have O in the middle. On both sides, you have a carbon-containing compound. Those are R. We're going to name it ether. And then we are going to have, so these two are one group. In the middle O, both sides are R. Okay, now we have a group of molecules that we will call as carbonyl carbon-containing molecules. And the first one is the aldehyde. So they all have the same setup. We're going to start with R. R is connected to C. Okay, and C is connected to double bond O. So this part is present in all of them. Okay, so what is on the right will determine what that molecule is. If that's only H, we're going to call it aldehyde. If that's another R, that will be ketone. If it is OH, that will be carboxylic acid. And if it is OR, that will be ester. And remember, or keep in mind, the name of this carbon is a carbonyl carbon. Okay, carbonyl carbon is attached to an O with a double bond, and there's a R on the other side. Okay, so if you kind of get confused and you don't know how to call the name, the R group, so alkyl is the R that we will be seeing. So it's very similar to if you have one carbon, we named it methane as alkane. When it becomes alkyl, it's methyl. It's CH3. So you are removing one of the hydrogen in each one of them. Okay, ethyl, propyl, butyl, pentyl, goes on. I just put this one as a reference there. Okay, why is it important to learn all of those different carbonyl compounds or carbon-containing compounds, all the organic compounds? Because each medicine you are taking or you are giving to your patients contains chemicals. Well, the medicines are, excuse me, chemicals, and they have all different kinds of organic compounds. And you want to know that how that drug interact with your patient, their body, how it is going to be removed from the body. Those are all important depending on which compound and which functional group the compound has. Okay, so pharmacokinetics, pharmacodynamics, and from the minute that the drug is administered, how it is absorbed, how it is circulated, how it is distributed and removed from your body, it all depends on what chemical compound there is inside that medicine. Okay, so we want to make the drug soluble so your body can take it by adding O's and N groups, but you don't want to make it too soluble that it is just removed without being absorbed into the body. Okay, so the first group is the alcohols. Another name for the alcohol we can say is a hydroxy. So when we say hydroxy, we are talking about this OH group that is present on the alcohol. Okay, that separates alcohol from all the others. It's the hydroxy group. Okay, so alcohol, general structure of alcohol is you have carbon containing compound attached to OH. Okay, so if that's your carbon, with the OH, okay, so that's your center of alcohol compound. If that carbon is attached to another carbon, just one carbon, we call it primary alcohol. If that your center carbon with OH, with the functional group, if it is attached to two carbon, then we call it secondary alcohol. So we really don't care about what is here, but we would care what is connected to the center carbon. Which one is the center carbon? Center carbon is the one that's connected to OH. So if there is one carbon that's connected to center carbon, that's primary. If there's two carbon, that's secondary. If that is two or three carbons, 1, 2, 3, where located or attached to the center carbon that contains the OH, that's a tertiary alcohol. Okay. As an example, what's the correct classification for the alcohol shown below? First, I have to locate which one is the alcohol carbon. I see the OH here. If that's the OH, okay, so my carbon that contains the OH is this one. So that's my center carbon. How many carbon is attached to this carbon? So I can see one carbon is attached on this side and one carbon is attached on this side. So since there are two carbons attached to center carbon, that makes it secondary carbon. Okay, how do we name the alcohols? No matter what, we are always numbering the longest carbon chain. Okay, so number the carbon chain and bring the lowest number where the OH is located. So now my priority is to locate the OH in the lowest carbon. Okay, and then you are going to, again, I'm starting with the alkane. So remember, it has the alkane. Okay, so we are going to drop the E and replace it with all. So what does that mean? So let's see. Let's count the carbons here. So this is 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon. Well, I can also label from the other side, right? 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon. Which one makes sense? I want to bring my OH to the lowest number. So then if I label from left to right, it brings it to number 4. If I bring from right to left, the yellow coloring, it brings it to number 3. So then I have to pick number 3. Number 3 is where my OH is located. And then I'm going to put dash. How many carbon? 6 carbon. What is the prefix for 6? Hexane, right? So I'm going to drop the E, replace the E with O. 3-hexanol because it has OH group. And if there are 2 OH groups attached, then we are going to use diol instead. So what does that mean? Let's count our carbons. 1, 2, 3, 4 carbon. If there's 4 carbon, what's the prefix for 4? Butane. Okay. Okay, because this is an alcohol, how do I know? Because the red one is now oxygen. Oxygen, oxygen. Okay. So red one is oxygen. I'm going to drop the E. So it's butanol. Where is my OH group located? I have one OH in carbon number 1. I have another OH in carbon number 2. Okay. So I have to tell where those OH are located. Carbon number 1 and carbon number 4 has OH group, right? Oops, it's butanol, not butanol. Okay. So 1,4-butanol. When I say butanol, it tells me there's one OH group, but there's 2 OH group. So then we make butane. Okay, so let's remove this. Butane, because there are 2 OH diol. All for OH. Di, how many? Name of the main carbon and where the OH are located. Okay, so when we look at here, which one is the alcohol? Remember, alcohol is the OH group that is attached to the carbon. There is one OH, looks like it's attached to carbon. There is one OH, but this is attached to, this next to the O. So this is COOH, and we will see this will be acid. There is no OH here, there is no OH here, okay? Then this will be the alcohol. If you have, okay, let's bring this one here. If you have a benzene group, right, we talked about this benzene group, it's an arene, that's a circular compound with the 3 double bonds. If it has OH attached to it, we call it phenol. And phenol is a very, very common compound that you see in many, many different medicines and compounds. Okay, so if you want to choose, let's say here, which one has a phenol ring, let's look at this one. This is a benzene attached to nitrate, so this is not a phenol because I'm looking for an OH group. Over here, there is no OH group attached. Over here, there's only chloride not attached. And this one, there's OH, but OH is not attached to the benzene ring directly. This also doesn't count. This is alcohol, but that's not a phenol. So none of the above will be the correct answer. Next group is ethers. Ethers. Okay. The ethers, we have an O in the middle, and O is attached to R on both sides. So when we are naming, we are going to count the carbon on both sides of the O, and we're going to name them separately. So R is alkyl. We're going to put the name of the alkyl, space, another alkyl, space, and we're going to put ether. Or if both R's are the same, we are going to say dialkyl ether. Okay, let's make put an example. And again, this is always the same thing. Put alkyl groups in alphabetical order. So if there's ethyl, methyl, so you have to put the ethyl first and the methyl. Okay, let's look at here. So I'm going to locate my O first. And I'm going to count the carbons on both sides. On this side, there's only one carbon. So that makes this molecule, what's the name of CH3? The alkyl. So with one carbon, it is methyl. Let's count the carbons on the other side. 1, 2, 3 carbons. What's the prefix for 3 carbon? Prop. Alkyl part is propyl. Okay. So now which comes first? P or M? M comes first. Then I'm going to say methyl space propyl, name of the second R, ether. And on this side, I have my O in the middle. I have attached CH3 on one side, again CH3 on the other side. So this is methyl. This is methyl. Okay, both of them are the same. Instead of saying methyl ether, then we're going to say dimethyl ether. Okay, the next group is aldehydes. So aldehydes are, we are going to recognize the aldehyde formula. You have to know their structural formula. So we have a carbon. So from now on, the remaining molecules will contain the carbonyl carbons. What was a carbonyl carbon? The C double bond O. So you have the C double bond O. On one side, it's R. The other side, it is H. Okay. How do we name it? We are going to, again, number our longest chain. Then we are going to have, for the longest chain, we're going to have the prefix ane. And we are going to drop that E and replace it al for aldehyde. Okay. And then if it has a prefix, you're going to put the number where the prefix is located, or the substituent, sorry, not prefix, where the substituent is located, and then you're going to put the name of the substituent. Okay. So let's see, let's look at this guy. So everything starts with counting the carbons. 1, 2, 3, 4 carbons. 4 carbons, my prefix for 4 carbons is butane, right? Okay. And I'm going to drop the E, replace with al. So this is butanal. Do I have any substituent? No, it's all hydrogen and carbon. Okay, it's all carbons. So this is butanol. Okay, let's look at this one. Now, let's name it. First, I'm going to count the longest carbon chain that contains my functional group. What's my functional group? It's CO carboxyl group, and then I have the H here. So if I have H, I know this is a aldehyde group, Al. Let's count the carbons. 1, 2, 3, 4 carbons. So 4 carbon, butan, because it's an aldehyde, butanal. Okay, do I have any substituent? Yes, I have one substituent here. One substituent, another substituent. Okay, so it's always my priority to start my functional group should be on the lowest carbon. So it should be 1, 2, 3, 4. Okay, where is my substituent? It's on carbon number 2, that's 1. Another one is on carbon number 3. Okay, so I'm going to put where my substituents are. My substituents are carbon number 2 and carbon number 3. Because they're both methyl, right? This is methyl. This is also methyl. Because they're both methyl, I'm going to put them together. 2, 3 dash, because there are 2 of them, dimethyl. That's my substituent. And the name of my main compound is with a 4 carbon butanal. How do I know it's aldehyde? Because I can see this CH double bond O. Okay, which one is the aldehyde? Now, for the aldehyde, I'm looking for carbon double bond. So when I look at those, okay, let's mark carbon double bond. Each one of them has carbon double bond, right? So it has a carbonyl carbon. Okay, on one side, I should have to the carbon attached to hydrogen. That makes aldehyde. This is hydrogen. There is no hydrogen. There is no hydrogen. There is no hydrogen. So this makes it aldehyde. The next group is ketone. So ketone, this is the general structure for ketone. What is it? You have the carbonyl carbon in the middle. On one side, it's R. On the other side, it is another R. Okay? It's the same R or a different R. Okay, so now this R was hydrogen in aldehyde. If it becomes R, it becomes ketone. Now again, when we are naming, you're always, if it has a substituent, you put where the substituent is. That number tells you where the substituent is, name of the substituent. And then you're going to put another number where your carbonyl carbon is located, prefix and ane. Ane, remove the E, replace with on for ketone. Okay, so let's make an example so it makes it kind of visible. Okay, first I'm going to locate my carbonyl carbon. So this is my carbonyl carbon, right? This is the carbon. This is another carbon. This is another carbon. This is another carbon. So now I'm going to count the number of the carbons. Okay, so this is 1. That's 2, 3, 4, 5, 6. You can also start from the other side. 1, 2, 3, 4, 5, 6. Do I choose red or green? I always want to bring the functional group on the lowest carbon. So if it is an alkene, you want to bring the double bond in the lowest carbon. If it is alcohol, you want to bring the alcohol OH group on the lowest carbon. If it is ketone, you want to bring it to the lowest carbon. So that's why we are choosing the red coloring, red numbering. It brings my carbonyl carbon to number 2. Okay, so carbon number 2 is where my O group is located. Carbonyl carbon is located. Now, I'm going to start with the substituent. Do I have any substituent? If this is my chain, is there anything sticking out other than O, because that determines the name of the group? So I have CH3. What's the name of this substituent? It is methyl. Where is it located? It's located on carbon number 5 because we are going with the red numbering. So 5 is where my substituent is located. What is my substituent? Methyl. And then I put a dash. Okay, now I have to name my ketone. My ketone is what? 6 carbon hexane, and we're going to drop the E, replace with on, hexanone. But I also have to say where my carbon is located, and it's located on carbon number 2. Okay, so let's name this compound. First, we are going to locate where my carbon is located. It's this one. And let's count how many carbon we have. 1, 2, 3, 4, 5. If I count from left to right, this is carbon number 1, 2, 3, 4, 5. If I count from right to left, 1, 2, 3, 4, 5. So in both cases, my carbon is located on carbon number 3. So let's do it. The name of my compound, 1, 2, 3, 4, 5. If it has 5 carbon, that is pentane. I'm going to drop the E, add O-N-E, pentanone. Where is my carbon is located? It's located on carbon number 3. Now I can add my substituents. If I have substituents. Do I have substituents? Yes. So I have one CH3 group sticking from this carbon, another carbon sticking CH3. What's the name of this? Methyl. This is also methyl. Okay, they are the same, and where they are located, where are my substituents located? One of them is located in carbon number 2, the other one is located in carbon number 4. What are they? Methyl, because there are 2 of them, dimethyl 3-pentanone is the name of my compound. Okay, next one. Let's start with numbering my compound. 1, 2, 3, 4, 5, 6 carbon. Okay, do I go from left to right, right to left? Let's see, 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Which one should I go with? I want to bring my carbon to the lowest carbon, numbered carbon. So my carbon is right here. So then I have to choose 3 with the red numbering. So okay, if I go with the red numbering, let's put the name of my compound first. 6 carbon hexanone. Where is my carbon is located? Carbon number 3. Now, do I have any substituent that's sticking out? It looks like this is sticking out. This is methyl. Where is it located? It's located on carbon number 5. 5-methyl 3-hexanone. Okay, the next group is carboxylic acid. So the carboxylic acid, now our formula, again, we have our carbonyl-carbon part that's attached to the R group on one side. On the other side, what are we looking for? It is ONH. Okay, so this is my carboxylic acid. So when we are naming the carboxylic acid, we're going to put the prefix that tells you how many carbon is there, anoic acid, to show that it is an acid. How do I know something is an acid? It has C, double bond O, OH. Okay, let's name this one first. So we're gonna always start with numbering our carbons. Let's locate our carbons, okay? And where is my carbon located? It's right here, okay? Oops, this is no, just a minute, let's do this. Okay, so there is no carbon, this is OH. Those are the carbons, 1, 2, 3, 4, 5 carbon. Okay, 5 carbon is what? Pentane, right? We drop E. This is my prefix. So I'm going to replace that E with anoic acid. Okay. I don't have to say where my carbonyl carbon is located because it has to be at the end because there is also OH group. Okay? Okay, let's name this guy. Let's see how many carbons are there. 1, 2, 3, 4 carbons. 4 carbons makes it butanoic acid. I'm sorry. Okay, how do I know it's acid? I have my carbonyl carbon and I have my OH together attached to the carbon. Okay, so it's butanoic acid. Do I have any substituent? Yes, I have NH2. How do you know the name of this one? You are going to have on your reference sheet. So NH2 is amino. Where is my amino located? So I'm going to be always starting with numbering to locate my carbonyl carbon and the lowest numbered carbon. So this is 1, 2, 3, 4. 4 carbon makes it butanoic acid. Then I'm going to add my substituent. Where is my substituent located? On carbon number 2. What's my substituent? It is amino. Okay, 2-amino butanoic acid. Okay. So now another special molecule, if you have the benzene attached to acid group, what is my acid group? C double bond O, OH. That's my acid group. So this is benzoic acid. Okay, now let's name this structure. I can say there is this benzoic acid with a benzene ring and acid group attached to it. Now I have to put where my substituents are located. So here, how do I know how to number? I want to bring the carbon that has the carbon acid, that has the acid group, the lowest number. So you can name or number the benzene ring. Okay, and this carbon has to be 1 because your carboxy group, it has the priority. If that's 1, that's 2, that's 3, that's 4. Okay, now I know the whole structure is benzoic acid, right? Because we know from here. And now I have to tell where my substituents are located. I have 1 bromo, 1 methyl. M comes before methyl, M. B comes before M. So I have to say then 4, where my bromo located, dash 3, where my methyl located, and the benzoic acid. Okay. Our next group is the ester. In the ester, we are looking at a structure of this compound. So we always have this carbonyl carbon group, right? We've been having it with aldehydes and ketones and alcohols and ethers. Okay, carbonyl carbon is here. On one side, there is 1 R group. On the other side, there is O and R prime group. We put especially R prime here because when we are naming, it's going to be important. How do we name it? We are going to put the name of the alkyl, which is the R prime. Okay. You're going to put the space. Then you're going to put the prefix of the R and anoate. When you're counting the carbons, you want to start with counting that brings your carbonyl carbon to the lowest carbon number. So let's name this one. So my carbonyl carbon is here. So I'm going to start numbering from here. 1, 2, 3, 4, 5. Okay. So I have 1 group on this side and I have 1 carbon on this side. So the carbon group or the alkyl group that's attached to the O is considered R prime, right? It was R prime here. And the carbon group that is attached to or on the left side of the O is considered as R. Okay, R and R prime. Now, when we are naming, we are going to start with R prime. What's the name of my R prime? Because there's only one carbon, this is methyl. So I'm going to start with methyl. Okay, that's my alkyl name. That's my R prime. I'm going to put space. Then I'm going to put the prefix of this R group. What's the prefix? 5 carbon. Pent. Okay, that's pentane. Okay, prefix pent. And I'm going to continue with anoate. Pentanoate. Okay, so it's a methyl pentanoate. Let's do this example. I'm going to locate my ester group, carbonyl carbon with O. And on the right side of the O, I will label it as R prime. On the left side, I will label it as R. Okay, we are going to start with the R prime. What's the name of R prime? How many carbon are here? 1, 2 carbon. So 2 carbon is ethyl, right? That's a alkyl group. So I put ethyl. Now I have to name the left part. How many carbons on the left side? Okay. So we have a mistake here. We are going to find out. So we start with ethyl, which is the R group. And then we are going to name, ethyl is the R prime. Now we're going to name the R group. How many carbons in an R group? 1, 2, 3. So we're going to, let's cross this naming here. Okay. And let's start 1, 2, 3. And if I have 3 carbon, okay, we start with ethyl, which is our R prime. Now we are putting space. We're going to name this part. 3 carbon is propanoate. Okay. So, but I have something else sticking out here. It's the prefix. Oh, that's the substituent. Where is my substituent located? It's on carbon number 2. What's the name of my substituent? It is methyl. So I have to put now ethyl. Okay, that's the name of the R prime. Now I'm going to name the R part. So I have 2 methyl propanoate. Okay. So name of the R group, keep saying R group. Name of the R prime, that's ethyl because it has 2 carbon. Then you go into the R group. R group has 3 carbon, that's the propanate. But propanate also attached to 1 methyl group on carbon number 2. So 2 methyl propanate is the name of this group. Okay. So in the exam, you are not going to have a complicated naming for those, but you would know that how to locate the functional group and know what it belongs to. So if you see double bond O with the O on one side, that's connected to R, you know this is an ester. Okay, so there are a couple questions, similar questions in the exam, so that's why I want to cover a couple of them. What's the common between aldehyde and ketones? So they're all different, maybe similarities or differences, but you know that they both contain carbonyl carbons. And with all of those compounds, we are comparing their solubility and boiling point. So when it comes to the boiling point or solubility, the more carbon you have, the higher the boiling point is, okay? And I'm going to give you this list that you can compare solubility and boiling point. Both of them, solubility and boiling point. Carboxylic acid has the highest, followed by the alcohol, then ketone, then aldehyde, ester, ether, and alkane. Okay, comes the last. So this chart you should know. On the next class, we're gonna add a couple more, and I'm gonna give you a more complete list, but for now those are all the things that we learned. This is how it goes. Carbonic acid or carboxylic acid has the highest one, alkane has the lowest one. Those are a couple questions that are using that information. Which of the functional group would have the highest boiling point? So we know carboxylic acid, carbonic acid is the same. So basically you can actually carboxylic acid, you can change that. Okay, carboxylic acid. Okay, and in this case, it's comparing their solubility of ethanol and ether. Okay, so where's my ethanol? That's alcohol. My ether is here. Which one is higher? Alcohol is more soluble in water than the ether. Okay, so that's the last one, and I will see you in the class.